Electronic musicians invest heavily in premium analog hardware, carefully selecting synthesizers to build a tactile setup. But when it is time to perform live, that physical gear is almost always forced to route through a desktop operating system. Syncing multiple devices on stage usually requires pushing data through traditional ASIO and USB MIDI driver stacks. These software layers act as required middlemen, and under heavy processing loads, they often introduce latency bottlenecks and system conflicts. Running a monolithic digital audio workstation on stage adds further risk. Traditional DAWs demand background internet connections, unexpected OS updates, and heavy CPU overhead during a live set. Achieving reliable hardware harmony requires removing the desktop audio layer from the equation entirely. Eliminating drivers is the only way to achieve the rock-solid, sample-accurate synchronization required for professional stage performance. This modular dashboard is Sy.Core. It is a local-first, progressive web app that functions as the master orchestrator for an entire hardware rig. The platform achieves this integration by utilizing the Web MIDI API. This allows the browser to communicate directly with Windows MIDI services and Core MIDI. This direct pipeline eliminates the need for proprietary driver installations or third-party routing software. While browser-based applications are often assumed to suffer from input delay, the Web Audio API executes a modular node graph that processes data with near-zero latency. Within this environment, the browser operates as a high-performance computation engine for outboard gear. Because the architecture relies on standardized web APIs, the system is universally accessible across Windows, macOS, Linux, and Android instantly from a single URL. Instead of spending hours configuring DAW routing tables and resolving driver conflicts for a specific computer, the entire rig can be booted up in seconds. Shifting master orchestration to a web-native architecture removes a significant point of failure in a modern live electronic setup. Looking at the platform's routing architecture, the first step is establishing inputs and outputs. Through auto-discovery, connected hardware instantly populates the environment the moment it is plugged in. Complex drop-down menus are replaced with a visual patch cable interface. Performers use intuitive drag-and-drop logic to establish direct app-to-device routing. This canvas handles advanced routing configurations, allowing for precise note range splits and multi-channel fan-outs across different synthesizers. These layouts are saved instantly. If a cable is pulled on stage, the entire routing map is recalled automatically as soon as the hardware is reconnected. A live MIDI traffic inspector monitors the data flow, providing fast on-stage debugging if a piece of hardware stops responding. This node-based approach digitizes the physical workflow of a hardware modular synthesizer. Visualizing this raw MIDI data turns abstract operating system logic into a highly readable, stable map for live performers. Beyond routing, the software takes an active role in sound design. The platform intelligently generates sound architectures, rather than functioning as a passive preset library. This is the sound engine interface, purpose-built for units like the Roland S-1. The algorithm computes mathematically balanced, stage-ready patches on demand. Every tweak made in the software interface sends an immediate control burst directly to the hardware. The sync is strictly bidirectional. Turning a physical knob on the actual synthesizer instantly updates the corresponding slider on the screen. Sy.Core also processes modulation outside the hardware's own limits, computing 2 additional software LFOs entirely within the browser. Using contextual MIDI learn, these software LFOs can be mapped to modulate physical hardware parameters that the synthesizer was never built to support. The algorithm also computes automatic A/B variations, giving the user instant alternative patches for rapid creative comparison. Raw control values are translated into readable visual feedback, allowing the performer to understand the exact structure of their patch at a glance. This continuous computational loop upgrades the physical hardware, creating a hybrid instrument distinctly more capable than the standalone unit. In addition to MIDI control, the system uses the Web Audio API to pipe physical audio back into the browser for manipulation. This is the audio capture interface. Recording is completely hands-free, automatically armed and triggered by the exact moment the synth sends its first MIDI note. The editor features precision leveling tools, including one-click normalization paired with a strict -3 dB peak ceiling and a noise gate threshold to zero out the floor. A dedicated crossfade engine processes the recording, rendering a gapless, BPM-aligned sample that is instantly ready for live playback. Moving to rhythm creation, this grid displays the algorithmic step sequencer. It populates drum patterns based on specific style algorithms, rather than requiring manual step entry. A dedicated bassline sequencer works alongside it, generating pitch and step data that is instantly routed out to the hardware over the established MIDI flow. Both the audio loopers and the generative MIDI sequencers are locked to a single, unyielding master clock to prevent any drift on stage. Unifying gapless audio capture with algorithmic MIDI generation establishes a rapid, self-sustaining loop between hardware inspiration and software execution. The final technical hurdle for a live performer is consolidating multiple sequences, audio loops, and synth patches into a single executable setlist. This sidebar lists performance sets. These bundles group specific program changes across entirely different hardware units, like an S1, a microfreak, and a seek track, into one selectable state. In the live set interface, these sets are mapped to a 16-pad grid. A performer can trigger sweeping state changes across their entire rig simply by striking a single MIDI controller pad. For structured sets, this live timeline arranges backing track segments along a linear axis. The timeline intentionally decouples the backing track from the MIDI transport. This allows automated UI commands and MIDI events to fire at precise timecodes, independent of the audio playback. Applying this high-level orchestration layer pulls a disjointed collection of studio hardware into a single, cohesive instrument optimized for live execution. Operating a web browser on a stage without reliable internet access carries obvious risks. Looking at the master deck dashboard, the platform solves this through local data persistence. Using service workers and IndexedDB, it severs its reliance on cloud connectivity. Every custom mapping, preset, audio buffer, and performance set lives on the local drive, guaranteeing an instant offline boot. The URL simply serves as a one-time delivery mechanism for an engine that performs like native desktop software. The entire toolset is completely free, open source, and driven by donationware, meaning there are no locked features or recurring subscriptions. This proves web architecture can handle the rigorous demands of professional stage environments, freeing DAW-less performers from the constraints of traditional monolithic software.